Good morning, class. I am Miss Amana Pikulat, your math teacher for today. And for today's session, we will be discussing about solving polynomial equations. Before we start our discussion, let us first recall the definition of polynomial equations. We have here polynomial equations are the expressions that contain monomial or polynomials with one term, binomial or polynomials with two terms, trinomial or polynomials with three terms, and also higher order polynomials. With that, we will now proceed to solving polynomial equations. So solving polynomial equations means finding the solutions of the polynomial equation. So the next question that comes to our mind is, how do we solve polynomial equations? So we will use our knowledge about factoring and synthetic division in order for us to solve polynomial equations. For us to understand further, let us have our illustrative example number 1. We have the polynomial equation x squared minus 25 equals 0. Notice that this polynomial equation is a special product which can be factored by the sum and difference of two squares. Factoring our polynomial equation, we have the factors x plus 5 times x minus 5 equals 0. Since we have factored completely our polynomial equation, we will now equate each factor into 0. For our first factor, we have x plus 5 equals 0. And then, using subtraction property of equality to find the value of x, we have x plus 5 minus 5 equals 0 minus 5. We know that 5 minus 5 is 0, so what remains on the left side of our equation is just x. And 0 minus 5 is negative 5. Therefore, x is equal to negative 5. For a second factor, we have x minus 5 equals 0. Using again the subtraction property of equality to find the value of x, we have x minus 5 plus 5 equals 0 plus 5. We know that negative 5 plus positive 5 is equal to 0, which means that the remaining value on the left side of the equation is just x, and 0 plus 5 is positive 5. Therefore, x equals 5. So the solutions for our polynomial equation are negative 5 and 5. For our illustrative example number 2, we have the polynomial equation 2x to the power of 5 minus 2x to the power of 3 equals 144x. From our first glance, we notice that our polynomial equation is not in its standard form. Therefore, we will transform the polynomial equation into its standard form using subtraction property of equality. Subtracting 144x from both sides, we now have 2x to the power of 5 minus 2x to the power of 3 minus 144x equals 144x minus 144x. Since there are no like terms on the left side of our equation, the values on the left side of the equation remains the same. On the right side of the equation, we know 144x minus 144x is equal to 0. Therefore, our new equation is 2x to the power of 5 minus 2x to the power of 3 minus 144x equals 0. Since our equation is now in its standard form, we can now use our knowledge on factoring in order to find the solutions of our polynomial equation. Factoring out 2x, which is the common factor, we now have the equation 2x times x to the power of 4 minus x squared minus 72 equals 0. Notice that x to the power of 4 minus x squared minus 72 is a quadratic equation in the form 2x times x squared to the power of 2 minus x squared minus 72 equals 0. Factoring out x squared to the power of 2 minus x squared minus 72, we now have 2x times x squared plus 8 times x squared minus 9 equals 0. Since we have factored completely our polynomial equation, we will now equate each factor into 0. For our first factor, we have 2x equals 0. Using the division property of equality, we now have 2x over 2 equals 0 over 2. We know that 2x over 2 is just x and 0 over 2 is just 0. Therefore, x is equal to 0. For a second factor, we have x squared plus 8 equals 0. Using the subtraction property of equality to find the value of x, we now have x squared plus 8 minus 8 equals 0 minus 8. For the left side of our equation, we know that positive 8 minus 8 is just equal to 0, and 0 minus 8 is equal to negative 8. Therefore, we now have our equation x squared equals negative 8. To find the value of x, we will now extract the square roots of the values from both sides of the equation. Therefore, square root of x squared is equal to square root of negative 8. Take note that negative 8 is an imaginary number. Therefore, it has no real roots. So, we now have x is equal to positive negative square root of 8i. And we know that 8 is equal to 4 times 2. Therefore, we can take out 4, which is a perfect square, outside the radical symbol. Finalizing, we now have x is equal to positive negative 2 square root of 2i. For our third factor, we have x squared minus 9 equals 0. The same from our previous factor, we will use subtraction property of equality to find the value of x. So that becomes x squared minus 9 plus 9 equals 0 plus 9. For the left side of our equation, we know that negative 9 plus 9 is just 0. And for our right side of our equation, we know that 0 plus 9 is 9. So we have x squared equals 9. To find the value of x, let us extract the square root of the values from both sides of the equation. Therefore, square root of x squared equals square root of 9. Square root of x squared is just x, and square root of 9 is just 3. Therefore, x equals positive negative 3. So the solutions of the polynomial equation are 0, positive 2 square root of 2i, negative 2 square root of 2i, positive 3, and negative 3. For our third illustrative example, we have the polynomial equation x cubed minus 6x squared plus 12x minus 8 equals 0. We will find the solutions of this polynomial equation with the use of factoring by grouping. So if we group x cubed minus 6x squared and 12x minus 8, we have the equation the quantity of x cubed minus 6x squared plus the quantity of 12x minus 8 equals 0. Factoring out the common factor for each group factor, we have x squared times x minus 6 plus 4 times 3x minus 2 equals 0. If we equate the factors of the polynomial equation into 0, we will notice that the number of solutions will exceed into 3, which is not possible because the degree of the polynomial equation determines the number of solutions for the said polynomial equation. Therefore, this is the wrong way to group the terms of the polynomial equations together. Therefore, we will try a new group, which is x cubed minus 8 minus the quantity of 6x squared minus 12x equals 0. Notice that x cubed minus 8 is a special product which can be factored using the sum and difference of two cubes. Factoring out the grouped factors, we have x minus 2 times x squared plus 2x plus 4 minus, factoring out the common factor for the group term 6x squared minus 12x, which is 6x, we have negative 6x times x minus 2 equals 0. We have a common factor which is x minus 2. So our next equation would be x minus 2 times x squared plus 2x plus 4 minus 6x equals 0. Combining like terms, which are 2x and negative 6x, we now have x minus 2 times x squared minus 4x plus 4 equals 0. Notice that x squared minus 4x plus 4 is also a special product which can be factored using the difference of two cubes. Therefore, the factors for our polynomial equation are x minus 2 times x minus 2 squared equals 0. And so that is just x minus 2 to the power of 3. Since we have factored completely our polynomial equation, we will now equate each factor to 0. That is, x minus 2 equals 0. Using the subtraction property of equality to find the value of x, we now have x minus 2 plus 2 equals 0 plus 2. On the left side of our equation, we know that negative 2 plus positive 2 is 0. And on the right side of our equation, we know that 0 plus 2 is 2. Therefore, x is equal to 2. And since we have 3 factors of x minus 2, so the solution for our polynomial equation is just x minus 2 with the multiplicity of 3. To sum this all up, solving polynomial equations is the process of finding the solutions of the polynomial equation. So the first thing to do in solving polynomial equation is always to transform the polynomial equation into its standard form. And then we solve for the solutions of the polynomial equation using factoring or synthetic division. This ends our discussion for today. Thank you for watching.